So as we begin this section, we're going to move from discussing quadratic equations to now discussing quadratic functions. So as a definition and a reminder, a quadratic function is going to start out f of x, and it's going to be equal to ax squared plus bx plus c. You're going to have numbers in place of the a, b, and the c, and the stipulation is that a cannot equal to 0. And we know that an equation or a function is quadratic based on the highest power of x. So if your highest power of x is 2, and that's what we're seeing here with this highest power of x being 2, then that tells me that we're dealing with a quadratic equation or a quadratic function. All right, so we want to talk first about what the graph of a quadratic function looks like. So if we have a quadratic function, it's going to graph what we call a parabola, which is one of these sort of U-shaped graphs that you see on the screen. So we need to be able to do a couple of things with the graph of a quadratic function. The first thing we need to be able to do is to determine whether the graph is going to open up like the red parabola in the picture, or if it's going to open down like the blue parabola in the picture. So the way that we determine whether the parabola opens up or down is by the a value in the quadratic function. So if the a is greater than 0, then the parabola should open up. And if the a is a negative number, less than 0, then the parabola should open down. So by looking at our pictures, we know that this parabola had an a value that was greater than 0. So it led with a positive number. And this parabola had an a value that was negative, so less than 0. The next thing that we need to determine is how to find that vertex point. Now, the vertex is defined to be the point where the graph sort of changes direction. So if you're looking at your red parabola here and we're tracing it, we notice that the graph is going down. When it gets to the vertex, it changes direction and starts back up the other side. We have a formula to find that vertex. And so the formula says that in order to find the x value of the vertex, we're going to take negative b and divide it by 2a. And then in order to find the y value, we're simply going to plug the x into the function. We'll look at that in just a second. And then the axis of symmetry is the vertical line that goes through the vertex. So the axis of symmetry comes straight down through the vertex. It sort of cuts the parabola into two different pieces that are mirror images of each other. So how do we find that axis of symmetry? Well, we know that that axis of symmetry is always a vertical line. And we know from our study on lines in the last couple of sections that a vertical line is always going to start out x is equal to, and it's going to be x is equal to a number. And again, as we look at an example in just a minute, we'll come back and kind of fill that in. All right, so let's take these three ideas and go to an example. So our function is f of x is equal to negative 3x squared plus 6x plus 1. So the first thing I'm going to do is I'm going to jot down my a, my b, and my c values. And that will just make things a little bit easier for me and prevent me from making a careless mistake. So remember that the a value is the number that sits in front of the x squared, so negative 3. And the b value is the number that sits in front of the x, so positive 6. And the c value is the number that sits by itself with no variable, and that's going to be positive 1. All right, remember our rule for whether it opens up or down. We're going to look at the a value, and since the a value is negative, it's less than 0, that's going to tell me that this parabola is going to open down. Okay, let's calculate our vertex. So remember that for your vertex, your formula to find the x value is negative b divided by 2a. So we're going to plug in. So in place of the b, I'm going to put my 6, and in place of the a, I'm going to put my negative 3. And then I'm going to work this out. So I have a negative 6 on the top, and 2 times negative 3, I have a negative 6 on the bottom, which is equal to 1. So my vertex has an x value of 1. Now I need to find the y value that goes with it. Well, I know that if x is equal to 1, in order to find the y, I can take my function and everywhere there's an x, I can substitute in a 1. So here, I can put a 1. And here, I can put a 1. All right, we'll simplify, so we'll do our power first. So negative 3, 1 squared is just 1. So negative 3 times 1 is negative 3. 6 times 1 is 6. And then we add 1 on the end. And so that's going to give me a positive 4. So now I have my vertex point, 1, 4. And now I need the axis of symmetry. Remember that the axis of symmetry is a vertical line, so it always starts out x is equal to something. And it goes through the vertex. So it is a vertical line that goes through the point 1, 4. So what is our x value in that point that it goes through? The x value is 1, and so my axis of symmetry will be x is equal to 1. All right, we're going to try one more example, very similarly, just to run through it one more time. Okay, so our next function is 2x squared plus x plus 1. Again, I'm going to take just a second and I'm going to write down my a, my b, and my c. This just prevents me from making a careless mistake. So my a value, the number in front of the x squared, is 2. My b value, the number in front of the x, is a 1. And my c value, also a 1, the number that sits by itself. Okay, so does the parabola open up or down? So I look at my a. My a is 2. 2 is greater than 0. Therefore, this parabola should open up. Let's find the vertex. So I know that my formula for the vertex is negative b over 2a. So I'm now going to, in place of the b, I'm going to put a 1. And in place of the a, I'm going to put a 2. So my x value for my vertex is negative 1 over 4. Okay, now we'll work on finding the y value. So remember, to find the y value, we're going to take our function, 2x squared plus x plus 1, and we're going to plug our negative 1/4 in for the x. So everywhere we have an x, I'm going to now put a negative 1/4. Okay, let's simplify. So I'm going to do my power first. So the negative 1/4 squared is going to become positive. I'm going to square the 1, and I'm going to square the 4. And then I just have a negative 1/4 plus 1. Now, at any point, you are welcome to use your calculator here. Okay, I'm going to go ahead and finish it up, but you can certainly type it in your calculator. So when I multiply the 2 times 1/16, I'm going to get 2/16 plus a negative 1/4 plus a 1. 2/16 reduces to 1/8. And then in order to actually combine these two, or 3 terms, we'll all need them all to have the same denominator, so they would all need to have denominators of 8. So I'm going to leave the 1/8 as it is. The 1/4, I'm going to write 2/8. And the 1, I'm going to write as 8/8. So now when we add these together, we're going to end up with positive 7/8. And that will be the y value in my vertex. Okay, so we have our vertex negative 1/4 and 7/8. All right, now we do our axis of symmetry. Again, this should be the easy part. Our axis of symmetry is a vertical line. So it starts out x is equal to, and it goes through the vertex. So what is the x value in the vertex? That was negative 1/4. So now we have the equation of the line that is our axis of symmetry.